Let's now take a look at this problem, finding the sine of the arc cosine of -5/9. Now, what is an arc cosine? Arc cosine is an angle, and it is an angle between 0 and pi. That is the range for arc cosine. And the reason it is the range for arc cosine, just to refresh your memory, if I take a look at the graph of cosine, it goes like this, roughly. And I need to choose a portion of the graph that satisfies the horizontal line test. Well, the portion of the graph that satisfies the horizontal line test that we typically choose will be the part that starts at 0 and ends at the first minima, which occurs at pi. So arc cosine is an angle that's chosen between 0 and pi. So this picture just gives a quick explanation as to why it's those angles. Okay, so let's now figure out arc cosine, or sine of the arc cosine of -5/9. So drawing the picture, I draw a picture so that the arc cosine is equal to -5/9, and so the picture will look something like this, -5/9, and so the angle theta here is equal to the arc cosine of -5/9. And we note again the angle is in the second quadrant and not the third quadrant because theta must be between 0 and pi. So we have a missing side here. To solve for the missing side, let's call that missing side y. So we need 25 plus y squared must be equal to 81. And so therefore y squared is equal to 56, I believe. And so y will equal the square root of 56. It must be positive because we have the angle in the second quadrant. And that works out to be 2 times the square root of 14. And so therefore the sine of the angle is going to be the y coordinate divided by the radial distance. So this is equal to 2 times the square root of 14 over 9. Now let's do a quick check to see if that actually matches what we have in the calculator. So if I take the sine of the arc cosine of -5/9, that works out to be this decimal. If I take 2 times the square root of 14 divided by 9, hopefully I'll get the same answer, and it matches. So that is the exact answer, 2 times the square root of 14 over 9.